So if you see the word optimization, does it make sense that it must be related to somehow doing the best thing? Like the optimal solution or the best solution? So that's what this is going to do, finding the optimal or best way of doing something. Okay, so the first thing is that suppose you have a graph of 6x plus y equals 9, and you want to find the point on that line that is closest to the point -3, 1. So let's visualize what's going on here. What does 6x plus y equals 9 look like? Is that the first question you have?
Same line?
Yes.
Yeah.
It is?
Yeah.
Your question statement looks a lot longer than mine somehow. Oh, it's because I have the little blurb in the beginning. Okay, that's why. Okay, so it's a line. Specifically, it's the line y equals -6x plus 9, isn't it?
Yeah.
Okay, so roughly speaking, it's got a y-intercept of 9, right? Slope of -6, so it goes down 1, down 6, forwards 1. So quite a steeply decreasing slope, right?
Could you remind me what the distance formula was?
Oh, we'll get there in a sec. I will do it. Okay, and then you want to find the point that's closest to -3, 1. So somewhere like that, right? So can somebody tell me why we asked for the distance formula? You want to find the point that's closest to this point, right? Which means that this distance is a minimum. Does that make sense? Okay, so here is the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. I keep mixing this class and my pre-calculus class. Did we talk about that one in this class already? No? Okay. It comes from the Pythagorean theorem. So here's sort of an easy explanation of why. So if that point has coordinates x1, y1, and this one has coordinates x2, y2, obviously the distance between them is the straight line, right? Now, how you can figure that out is you can construct a triangle, a right triangle. And that right triangle, this side is highest y minus lowest y. That's the y2 minus y1. This side is right x minus left x. And call this side d for distance. And then if you do x2 minus x1 squared plus y2 minus y1 squared, you get, that's d squared. And then you root it and you get the distance formula. It comes from the Pythagorean theorem. And it doesn't actually matter if this point is both above and to the right of that point, because when you square this x2 minus x1, it's going to be positive no matter what. Yeah?
So the way you wrote it, like with this side is y2 minus y1, is that y2 minus y1 squared?
Once you plug it into Pythagorean theorem, it is.
Okay.
Right?
Yeah.
Because the Pythagorean theorem says that a squared plus b squared is c squared, right? And the a happens to be x2 minus x1. And the b happens to be y2 minus y1. So that's where that comes from. But you will have to know the formula, so it's a good one to just kind of write down. That's a memory tool as to why.
Does it matter if we switch to the y side?
Nope, does not. Yep, nope, because addition is commutative. Yep, doesn't matter. As long as you keep the hypotenuse as the hypotenuse, that's the important part. Okay, now you want to find the point that is closest to the point -3, 1. So the idea is you have some random point, x, y. So we're just going to let that be x, let that be y. And then you want to be closest to this specific point, -3, 1. So that gets plugged in for your x1 and your y1. So that becomes x plus 3 squared, y minus 1 squared. It doesn't matter which order you do, like a general x and general y, but it's easiest to let the, I think, the fixed point be the number after the subtraction sign. It'll make your differentiation process easier. You know, what fact haven't you used yet? Like this is like saying we have some random point x, y on this line. So you've got a point x, y on the line and you have the specific point negative 3, 1. If you're on that line, what's true about your y value? Like, can you make this equation somehow have one variable because you know of a relationship between x and y? Yeah, what can you use? You can use this, right? Use the fact that y is negative 6x plus 9. So plug that in. And then this formula will tell you the distance from that point, negative 3, 1, to the line, no matter what your x is. Or it's root x plus 3 squared plus, what's that, negative 6x plus 8 squared, right?
Now do you just solve for x?
Kind of, okay, almost. So this formula tells you the distance between the line and that point for any x. You want to find the closest point, which means you want to find what of this function? Closest corresponds to it, this distance being a minimum or maximum. Minimum, you want to find the minimum. And how do you find minimums and maximums? Take the first derivative. Now, before we do that, how about we take this stuff inside the root sign and like expand and combine like terms? Does that make sense? But the idea is you have this equation that tells you the distance. You want to find the minimum of the distance, because that would be the closest point. Okay, so let's expand and simplify. So what is x plus 3 squared? And then negative 6x plus 8 squared is 36x squared. I think minus 96x plus 64. It wouldn't, because negative 6 times negative 6 makes positive 6, 36. Do you agree with my 96? Because that's, when you square a plus b, what's the formula? 2ab plus b squared, right? That's why I got this be 96. I did 6 times 8 is 48, and then times 2 is 96, right? Okay. And then combine like terms a little bit, and you get root 37x squared minus 90x plus 73, I believe. Okay. So that is our distance formula for this specific line. That specific point will be different for different functions and different points. You want to find the minimum, so now you take the derivative, yep, and it will be 1/2 stuff to the power of negative 1/2 times derivative of your stuff, which is, it's not that bad. What's the derivative of 37x squared minus 90x plus 73? It's going to be
74x
minus
90.
and then 73's derivative is 0, right? What do you set the derivative equal to? 0. So I'm going to do that. So 0 equals 74x, excuse me, minus 90 over 2 root 37x squared minus 90x plus 73. You could divide the 74 and 90 both by 2, but I want to leave that 2 there just to show you an easier way to do this problem in the future. Does the denominator matter here? Not really. So it's going to go away, and we're going to get 0 equals 74x minus 90, and then solve that for x, right? So 90 equals 74x, and x is 90 over 74. What does that reduce to? It doesn't reduce much, but you can at least divide by 2, can't you? 45 over 37. I think 37 is prime, and so that's it. So that's the x-coordinate of the point that is closest to the point, -3, 1. How do you find the y-coordinate?
Just plug it into the original function.
So -6 times 45 over 37, was that plus 9?
Yeah.
Okay. So once I got common denominator and all sorts of stuff, I got 63 over 37. So there are the coordinates. Okay. Now there's one slight problem. I boxed my answers a little bit prematurely because technically, if you set the derivative equal to 0, do you know that that's a maximum or minimum? Like, it doesn't tell you. You could have found a min, you could have found a max, right? So you could have accidentally found the point that was farthest away from that point as opposed to closest. Does that idea make sense? So in order to verify that this was a max or a min, you'd have to use either the first derivative test or second derivative test. Does that make sense? And to do that, I want to show you a shorter way to do this problem in the first place. So first of all, notice that every single distance formula that you're going to have when you work it all out is going to have a square root in it, right? And whenever you differentiate that, it's going to be 1/2 stuff to the -1/2 times stuff's derivative, right? And is this stuff in the bottom ever going to happen? Ever going to matter? No, not for a single one. All that matters is the derivative of the inside stuff, right? So what your book does, instead of using f of x equal to d, it lets a function f of x be distance squared. And then it minimizes / maximizes, whichever applies, this instead. Yeah, so what you're going to do is you're going to use, instead of that, you're going to say, I'm going to need a new slide here. Because apparently, okay, there we go, I can move that in front of me. Okay, there we go. So what they would have done is they would have said, okay, we're going to let f of x be equal to that 37x squared minus 90x plus 73 instead. And it's going to be the same answer every time. If you just look at the one that has the root, and you can convince yourself pretty quickly that that's going to happen. So what I would say for this is figure out what d is equal to, and then let f of x equal distance squared, and minimize that. And said you're allowed to use that shortcut, because it will be a lot easier. Does that make sense?
And you still set it equal to 0.
Yep, you still set it equal to 0. Yep, you still solve like normal. And the super nice thing about this is it lets you determine that the point that you find is a max or min really quickly. Because we would have f prime of x is, so is that 74x minus 90. And the second derivative is 74, right? And since the second derivative is 74, this means that f is concave up or concave down?
Concave up.
F is concave up. And thus, at x equals 45/37, we have a min or max. Have a min.
There
And
is no
that's
max.
by the second derivative test. So then you've justified that the point that you found actually is a smallest point. And I will ask you to do that in your answers on your quiz. I'll say justify why you have found a max or a min. You'll have to give me a short explanation. And the second derivative test is often easier. Because you can say, okay, the second derivative is the simple thing. Usually you'd have to plug in the number that you got, but my second derivative was a constant, which means my function is always concave up. The function you have was a parabola, right? Does always concave up make sense for that parabola? Yeah, okay. All right. Ready for the next one?
1 second.
Yeah, no problem. So I think the next question is kind of a cool one. Okay, so you're making a can and you want it to hold a liter of oil, which seems like a logical thing that you would do, right? Because you sell liquid things. And you want to find the dimensions that are going to minimize the cost of metal to manufacture the can. This means you want to minimize the surface area. Does that make sense? That's the part that determines how much your can costs to make, how much surface area it has. Okay. Do you know the volume of a right circular cylinder?
It's pi r squared times height.
Mm-hmm. Can you think of an easy way to remember that?
I think of it as the circle times the height.
Which is what it is the area of the base times the height, right? Okay. Now what would the surface area of that thing be?
2 pi r squared plus...
Yeah, so 2 pi r squared, does that part make sense? That's the bottom of the can plus the top of the can. Does that make sense? Okay, and then...
Plus pi...
yeah.
2r times height.
Yes, good job. Okay, plus 2 pi rh. Okay, I think that last part needs a little bit of explanation though. Does everybody understand the whole 2 pi r squared part? That's just the top and bottom. Okay, the 2 pi rh, that's the surface area of the side, like this part of it, right? And the way that you find that is if you cut your can down, it's going to produce a rectangle before you spin it into a cylinder, right? And so the height of that is h. The question is how long is this side? And that side corresponds to the circumference of your circle. Does that make sense? It's like if I took this paper and made it into a can, right? I have the height and then this is the circumference. And so the circumference of a circle is 2 pi r. Okay? All right. Okay, now what do you know about this can? Do you know its volume or do you know its surface area?
You know its volume.
You know its volume. And so the first thing that's a little bit tricky in this question is 1 liter of oil. You have to convert that into cubic centimeters. So metric is nice. Pretty sure 1 liter is 1,000 cubic centimeters. So I would give it to you like in the 1,000 cubic centimeters already because I just think it's too tricky. But 1,000 equals pi r squared h.
You wouldn't give us a gallon and tell us...
Oh God, no. God, no. No, that would be like a real life problem where you have calculators and lots of time and maybe some help. Group work. Now the thing is with this A equation, you want to find the minimum of this, right? Why can't you take its derivative right now as is? What's the problem with it?
There are 2 variables.
Yeah, there are 2 variables on the right-hand side, right? So, and that was the same thing with our distance formula when we first started, wasn't it? It had both x and y in it. Okay, so what the situation will almost always be is you have to somehow incorporate this information, which we were given a point in the last problem. In this problem, we're given some information about the volume into that equation, and do so in the easiest possible manner. So is it easier to solve for r or h in that equation that I have a box around? Heck of easier to solve for h. So h is 1,000 over pi r squared. And you can input that. And you have a is 2 pi r squared plus 2 pi r times 1,000 over pi r squared. And then simplify. I think that's going to be 2,000 over r. Do you guys agree with that? Okay. So once your equation's down to 1 variable, you're going to find the max or min of that equation. And to do that, you use the derivative, right? That's the same process we have. So once you get the equations, it's the same as finding a max or a min for anything else. So what's the derivative of this a function? 4 pi r. Okay, so what's the derivative of 2,000 over r? Negative 2,000 over r to the second. Does that make sense? Because that really is r to the negative 1. So the negative 1 pulls down and then drops down by 1 more. And now what you do with this thing once you've got the derivative. So 0 is 4 pi r minus 2,000 over r squared. I'm going to add the 2,000 over r squared to the 0. So I get that. What next? Sure. 2,000 will equal 4 pi r cubed. Divided by 4 pi, yep. So r cubed is equal to 2,000 over 4 pi. And that can simplify like a little bit into over pi. So weird as it is, r will be the cube root of 500 over pi. And you're probably not going to give your manufacturer that specific dimension. You're probably going to like use a calculator and estimate what that is, right? You're going to say, okay, round to the nearest whole number.
I feel like if we had to learn it, they had to learn it, so I'd give them that number.
You feel like you give them that number to sound really smart?
Yeah,
You'd be like, figure this out.
I'd hope for the best.
Well, if we work for them, they clearly have the higher point in this. So.
Exactly, yep. Okay, so before you give your manufacturer this number, you want to make sure it is actually the best one, right? So let's go ahead and first figure out that it's a max or min. So I think it really is easiest to use the second derivative test. So the second derivative of that function is going to be 4 pi. And is it okay if I say plus here next? Because think about that over r squared. It's really r to the negative 2, right? The power pulls down, so the negative 2 multiplies by that 2,000, making 4,000. And what's the new power on that r? It becomes over r cubed. Yep. And you don't even have to do very much with this r. So this a prime prime is not always going to be positive or negative, but what matters is what happens at the r that you found. So a prime prime of the cube root of that stuff, you don't have to find it exactly, but tell me, is it bigger than 0 or is it less than 0? And that's very easy to tell. If you plug in that number, you're going to get a positive answer or a negative answer. Positive, right? Because you're cubing a positive thing, you get a positive thing. And so is A concave up or concave down? Concave up. Thus, we have a min or max. Okay, that's the second derivative test. Concave up, right? Like a cup, means you have a lowest point. And is a min what you wanted? I think it is. Yes, victory, yay, okay. So all we have to do now is give our manufacturer the other dimension. Do you know what I mean by that? So we have the R, we need to give the manufacturer the H. Does that make sense? So the H is equal to 1,000 over pi r squared, right? So it ends up being 1,000 over pi times cube root of 500 over pi squared. And after some painful, tricky algebra, oh man, I hate tricky algebra. All right, 1,000 over pi, 500 over pi to the 2/3. I'm not going to make you do tricky algebra because I just think it's just annoying. 2 times the cube root of 500 over pi. is what you get. So the height is twice the radius. You can get that by doing some funky things, and actually that's actually not that bad. You think about this as 2 times 500 and pi 500 to the 2/3 power over pi 2/3 power. Okay, that's the trick. And then what happens is the exponent on the 500 and the 500 to the 2/3 subtracts. 1 minus 2/3 is 1/3, right? And the same thing on the pi's. 1 minus 2/3 is 1/3. That's why that works that way. It's weird, tricky stuff though. But the kind of cool thing is that the ratio of radius to height is that the height is twice the radius. It's kind of cool. Go home today and measure like a Coke can and see like, is the radius really like twice, is the height really twice the radius with that can? Like, is that the relationship? It might be. Because maybe they had some calculus that worked for them. So that was an example from your textbook, and it's a bit harder than I make you do, but it's a kind of a cool application, I think. I'll make you do stuff where it isn't quite as ugly of arithmetic. Like stuff like this. So you want to make an open box, and just to make it simpler, your open box is going to have a square base, and its surface area is going to be 108 square inches. And you want to know can you make the biggest such box?
I believe I remember your exact words in pre-calculus saying we were done with this problem.
Oh, no. Well, in that class. Everything that I said in that class applies to that class. This is a little bit different. This isn't a box where you have, the one we did in pre-calculus repeatedly was where we took a box and cut up the corners. We're going to do that problem again. And you're going to be so good at it because I made you do it like 5 times. Okay, so one thing we know about this box is that the base is a square, which means the 2 sides of that base are the same or equal. Yes, I'm going to call them the same letter then. XX. I just like to use X because it's my favorite letter. It marks the spot. All right, now, do we know that the height is the same? Does it say the height is the same as the size of the base? No, so then you have to let the height be something like else, like Y. Okay. What dimensions are going to produce the maximum volume means you want to maximize an equation that talks about the volume. So what is the volume of this box? X squared times Y, exactly. So that gives you the hint that this is the equation you're going to take the derivative of. Does that make sense? Because it says find the maximum of this thing, means you're going to differentiate the function that tells you about that thing. Now, you also know that the box has to have some specified surface area. So for this particular box, it has an open top, which means it has how many sides for the surface area? 5. We're not going to count the inside like they do in Doctor Who. So one side is the base, which is x squared, right? What is the area of every other side?
Y times X,
Y times x, yep. And how many of them do you have?
4.
4, so 4xy. And do you know what that area has to equal? 108, yep. 108 equals x squared plus 4xy. Almost all of these problems are going to involve taking 2 equations and putting them together. They've both been like that so far, right? There was we put the y equals stuff into the distance formula, right? We put the equation about the volume into the surface area thing, right? So solve this for the easiest variable possible, which is probably,
H.
oh yeah, in your case h, in my case y, yes. 108 minus x squared equals 4xy, or 108 minus x squared all over 4x equals y, right? Does that make sense? And then put that in the other equation. So v equals x squared times 108 minus x squared over 4x. And if at all possible, avoid the use of the product and quotient rule by simplifying. Okay? So what can you cancel? You cancel an x, we'll have x times 108 minus x squared over 4, or 108 over 4 times x minus 1/4 x cubed. Do you guys buy that?
But 108 over 4 is 27, right?
Yes, it is. 108 over 4 is 27. Is that what I have in my notes? I can't tell. So 108 divided by 2 is 54. Divided by 2 again is 27. Yep. Okay. Great. Once you've simplified that volume equation down as much as you can, then you do what? Take the derivative, yep. So v prime is equal to 27 minus 3/4 x squared, spectacular. Set it equal to 0. 0 equals 27 minus 3/4 x squared. So 3/4 x squared equals 27, right? X squared is 27 times 4/3. And because if I don't give you a calculator, it's good to know tricks to do this stuff well and quickly. Is it easier to multiply by 4 first or divide by 3 first? Divide by 3 first, right? That becomes 9 times 4, which is 36. And so x equals
Plus or minus 6.
6. And not, in this case, not -6 because like it's a base of a rectangle, a physical object, and it can't have negative, like, width. Okay. Before we move on, let's make sure it's a max or min. Does that make sense? So let's see, I think, and if it's easy to take the second derivative, just do so. Is it easy to get the second derivative? Yeah. So v prime prime is equal to, I think, -3 over 2x. Because it, Yes, okay. And v prime prime of 6 will be less than 0. Like when you plug in that critical number you found, your second derivative is negative. Negative means concave what? Down. So thus v is concave down, and x equals 6 is a max. And is a maximum what you wanted to find?
Yeah.
Yeah, it is. Okay, so we're good. We're in business then.
How would you know if you try to find a minimum and you found a max?
You might have just found something that was a minimum, not a maximum, and then there'll be. We'll have an example of that because they're hard to make. They're hard to produce. Usually, you find what you need, and you're just verifying that it's actually so. But you wouldn't make it. You wouldn't like make it right. Like there's something you didn't like make a mistake. It's just that you might have to use like an endpoint or something like that to produce the best volume. Okay, I think you were asked for the dimensions, right? So the base is 6 by 6. That's what that x stood for, right? And it was, what were the units on this guy? Square inches, so it'd be 6 inches by 6 inches, right? And the height, how would you find the height or the y? You could use this equation, couldn't you? Does that make sense? So your height would be y, which is 108 minus 36 over 4 times 6, which is 24. So what's 108 minus 36?
I don't want to get that in my head.
Oh, it's not that bad, isn't it? Yeah, it's 72, right? And I think that's 3. Do you agree?
Yeah.
Okay. Mm-hmm.
For the base, can you just put it in 36 square?
It wants dimensions, so that would set, so dimensions mean like what's the length, what's the width, you know? So you do have to say like 6 by 6. I'm pretty sure WebAssign will be sort of smart and give you like 3 boxes, so it kind of gives you a hint as to what it wants the answer to be. But yeah, to give it a 6 by 6. Okay. That's a bit easier than the can one, right? Just because it's just less tricky. Oh, I didn't leave you enough space for. Bad me. Okay. Right, really small. Okay. This will be the first example where you have something sort of weird going on. So you have 4 feet of wire. Okay. And you're going to cut it, and you're going to make a square and a circle. So I'm going to call this x, and this part is going to be 4 minus x. And that's my cut point. And this first part I'm going to make into the circle, and the second part I'm going to make into a square. It wouldn't, but it will be easier to let x be the circle. So that's just because I have some experience with this problem, but you can let it go either way. So the idea is you're going to have these 2 pieces. You're going to have a circle and a square, and you want to say, where should I make that cut to make the absolute best, like enclose the most area? And one thing that they don't really specify very well is it's okay to have all circle or all square. You could not cut the wire at all and just make a circle or make a square, or you could make both and see which one encloses the most area. Does that idea make sense? Okay. So the total area enclosed is going to be pi r squared plus s squared, for say s is the side of that square, okay? Let's start with the square. This 4 minus x, that's the perimeter of the square. Does that make sense? So 4 minus x equals perimeter of the square. So if each side of my square is like s or something, how many sides do I have? 4. Yeah, so 4 minus x will equal 4s. So therefore s will equal 1 minus a quarter x. Does that make sense? So if 4 minus x is the total for all 4 sides, take that thing and divide it by 4, and that gives how much each side is. This x is the perimeter of the circle. What is the, how would you find the radius from the perimeter? Kind of did this already. The circumference of the circle is the same thing as the perimeter, right? So c is 2 pi r. So x equals 2 pi r, and r is x over 2 pi. So you kind of had to convert 2 equations to both have the same variables in them. Yeah.
Sorry, on the surface area for the square, why did you times surface by 4 again?
It's not the surface area, it's the perimeter. Because there are 4 sides in a square. Okay, so then the area equation is pi times x over 2 pi squared plus 1 minus a quarter x, the whole thing squared. And just simplifying a little bit, we have pi times x squared over 4 pi squared plus 1 minus 2 quarters x plus 1/16 x squared. The pi's can cancel, yep. So you'll have a equals x squared over 4 pi plus 1 minus a half x plus 1/16 x squared, right? Is that okay? All right. Now, this is the equation you want to find the max or minimum of, right? So take the derivative. So a prime will equal 2x over 4 pi minus a half plus 2/16 x. Let's set it equal to 0 and reduce. So x over 2 pi minus a half plus an eighth. Is everyone okay with that? No, this is me doing a bit of a trick because I would like to get rid of those fractions. So how could I get rid of the over pi business? What could I multiply by? Pi. Does that make sense? I'll put pi in the numerator. What number would I multiply by to get rid of all of the denominators? Well, we'll cancel them all out. I think 4 won't quite do it. 8. Because we want to also cancel out the 1/8. So if I distribute 8 pi to everybody, I get 0 equals 4x. You buy that? Minus how many pi's? 4 pi plus what comes next? Pi x. Great.
Let's talk of pie is making me hungry.
I know. I had pecan pie this weekend. It was awesome. 4 pi equals 4x plus pi x. It's a little bit like that not related rates, implicit differentiation thing, right? You've got two x's on the same side. You want to solve for that x. You factor it out. 4 pi equals x times 4 plus pi. And so x equals 4 pi over 4 plus pi. It's ugly. It's about 1.7596. Okay, you got that? It's not really it was tricky to get the formula in the first place because you had to sort of find the radius and the side of the square, but it's just gross algebra after that. Okay, now let's try to, since we're giving our boss specifications, we're going to find the second derivative. So the second derivative is what? So the first derivative was this guy, right? So I think it's going to be 1 over 2 pi plus an eighth, right? Do you agree with that? Okay. So A is concave up or concave down? Concave up. And x equals 4 pi over 4 plus pi is a concave up means a minimum. Is that what you wanted? Okay, crap. Or carp. Well, does that make sense that is correct conclusion, right? This is a minimum. We didn't want to find a minimum. We want to find a maximum, right? So what you have to do then is you have to test all circle, all square. Does that make sense? Your thing could have been, you could have taken that whole thing and made it a circle, right? Could have taken the whole thing and made it a square. So look at your equation for your A. Your A is equal to this x squared over 4 pi plus 1 minus a half x plus 1/16 x squared. If you go all circle, so look at that little diagram up top. If you go all circle, what is x equal to? Or here's an easier way. Let's do it a different way.
Can you scoot that bottom part up further,
Sure.
please?
Hold on a second. Okay. So you had this piece of wire that was how long? 4 feet, okay. So 4 feet. So if you made it into a circle, you know that the area of the circle is pi r squared, right? And you know that the circumference is 2 pi r, and therefore 4 equals 2 pi r because you used the entire part of the wire to be your circumference. So r is equal to 2 over pi, right? You buy that? So then in that case, the area is pi times 2 over pi, the quantity squared, or 4 over pi. You buy that? Okay, what if you made it all a square? What would be the size you'd have on each side if the whole perimeter of the square was 4 feet? Which each side going to be? Each side's going to be 1, right? So the area would be 1 squared or 1, right? Because you divide that 4 up into 4 equal pieces, right? Or you could say, you know, the perimeter of a square is 4s, right? Therefore, 4 equals 4s. My side is 1. Which one of those is bigger, 4 over pi or 1? 4 over pi. So this is the max.
I wanted to do the circle props.
Yeah, that probably is, yeah, probably also, yeah. If you really wanted to, like, say, build a house, given a specific amount of stuff on the outside of the house, you would build it in a circular shape, but that isn't efficient building practices. But yeah, if you want to, say, take some fence and you want to fence in the most area by making a square, a circle, or a square and circle, you should fence in a circle. So, yeah. What this problem kind of points out is that sometimes these problems are affected by the fact that these functions have domains because they're in the real world, and certain things in the equations don't make sense because they produce, like, say, negative areas and stuff like that. So I would say it's probably easiest to not worry about the domain issue unless you run into a problem where the thing you find isn't what you want it to be. Does that make sense? And then just think, oh, could I have been all one or all the other? So.
So it doesn't matter if the question says circle and a square?
Say that again?
Well, the thing says a circle and a square.
Yeah.
So
There'll be a pretty obvious sort of, like, you could be all one or all the other kind of a thing going on. Yep.
This question they asked for how much of each, right?
Yeah. And I mean, what they should have done probably in the explanation is said, like, it's legitimate to be all one or all the other. Because that wasn't obvious either, I think.
You have to include some squares, you said the limit is 0.
Yeah.
So the answer would just be all.
And then I think that officially, okay,
So the answer is we should use 0 for the square.
we should use 0 for the square, all for the circle. Don't make any squares. Don't be square. Okay. Now, here's another application to economics. These make much more sense, and they're a bit easier because we talk about really simple situations. So suppose you're making computers and you're selling them for $350, $350 each, and your marketing department estimates that you're going to sell 80 more tablets if you decrease the price by $10. So we're going to find this thing called the demand function. And what the demand function says is you have X always equal the number of units you're selling. And this demand function tells you P what the price will be for selling that number of units. And to make this stuff work out easily, we pretty much always let X equal how many of what you're selling. You can do this math with using X in a different manner, but it's just easier to do it this way. And your textbook will do it this way too. Okay, so you know a specific, and we're assuming the demand, we're gonna find the demand function, we're gonna assume that it's linear. So you know one ordered pair already. So think about P as like your Y. So you know if you sell 1,200 tablets, how much are they selling for?
350,
350.
1280, 340.
Uh-huh. And 1280, 340. Do you guys see how he got that? The second part says that if you decrease the price by 10, the number of things you sell increases by 80, right? Okay. So using those 2 points, can you get an equation of the line? Yep. So the slope will be 340 minus 350 over 1280 minus 1200. And that's what, negative 10 over 80, right? Or negative 1/8. Great. 0.125, yep. So y minus y1 equals m, x minus x1. So y minus, let's use 350, equals negative 1/8, x minus 1200. Okay, so what's 1200 divided by 8? So it's 600 over 4, right? Thanks. So your demand function is negative 1/8 x plus 500. And your book usually calls this P of x, P for price.
So what did that really tell us?
It tells you that if you say want to sell 100 tablets, what should your price be? Does that make sense? It tells you the cost of one tablet. Think about what the y and the x were. X was the number of units you're selling, right? P is the price of those units. So you plug in how many units you're selling or want to sell and figure out what the price should be. So if you want to sell, I don't know, 400 of those things.
I thought it was telling us how much we'd sell if we dropped the price 10.
It's not. Yep, that's definitely not what it's telling us. It would if you solved it for x. Yep. Okay. So what should the price be in order to maximize the revenue? So revenue is how much money you've pulled in, right? So in general, revenue is going to be equal to the number sold times the price per unit, right? How many you sold times how much they cost. And this is where the fact that you let x was equal to the number of units sold, right? And that P of x function we found in part A, P of x is the price function, price or demand function. So because of how we chose to set up part A, that will affect how we're going to do this part B. So it's x times P of x, yep. Or x times the function you found in the last one, which I already forgot, but I think was negative 1/8 x plus 500. Is that correct? So that's negative 1/8 x squared plus 500x. And it's just a design choice. You can do this a different way. It's totally possible, but your textbook will always let x equal the number of units you're selling. So it's just how they do it. So you want to find the maximum of this? How do you do that? Take the derivative, yep. R prime of x will be negative 1/4 x plus 500. Set it equal to 0. Does that make sense? So 1/4 x equals 500, and x will equal 2,000. So 2,000 tablets, that's how many tablets? So now you have to figure out how much should they cost. How would you figure that out? Put it into the price function. So you find P of 2,000. So that'd be negative 1/8 times 2,000 plus 500. So what's 2,000 divided by 8? Hopefully it's not a negative number.
I don't know about this.
250? Okay, so negative 250 plus 500 is 250. So the price you should set them at is 250 and you will make the most revenue. You'll make more selling them for less because you have sold more tablets. I'm gonna pause and say something I shouldn't say on air.
I was gonna-
So read part C.
Huh?
Read part C.
Can't read that.
Yes, you can. You've got glasses.
Ah.
Sorry, I'm sassy this morning.
I think we should have started with C.
The point is they're going to be a little bit similar. So part B, you're right, you didn't factor in how much those tablets cost you, okay? Like that is something and that does matter.
See, I
So,
thought that's what we got from A.
but you have to use revenue to find cost, so there's a
Yeah,
reason.
okay.
So if so you know that so for some, you somehow determine that your cost function is this. And it probably is the case that you have this certain upfront cost, like your rent, plus you have some kind of like per tablet cost kind of thing going on.
Labor.
Yeah, labor or materials, right? That might also be a per labor thing, per tablet cost. So how should you set your price so you can maximize your profit? So profit, as a general rule of thumb, will equal your revenue minus your cost. And that's the reason I want to do revenue first, is because you have to know what revenue is to talk about how you'd find profit. And your book calls profit capital P of X, whereas that demand function is a lowercase p. So P of X is R of X minus C of X. And R of X was still that X lowercase P of X thing we found before, right? Minus this C of X function. So what was that? That was like X times negative 1/8 X plus 500, right?
Yeah.
Minus the cost function, which is 3,500 plus 120X. Or simplifying a little bit, negative 1/8 X squared plus 500X minus 3,500 minus 120X, or negative 1/8 X squared plus 380, right? X minus 3,000, 35,000. Okay, is that all right? Okay, now can you find the maximum of this function? Take the derivative. So P prime of X will be negative 1/4 X plus 380, right? Set it equal to 0. So 1/4 X equals 380, and X is going to equal, I got 1,520.
That's not the units though, right?
That's how many tablets you're going to sell. You gotta remember that if you write down that X is number of blah, that's,
Keeps on translating through, so
you still got to find the price. Yep. Yeah, the variable thing carries through because that variable definition determined that we used X P of X and not something else. Okay, so how would you find your price then? What do you plug that little thing into? The first one, yep. So little p of 1520, or negative 1/8 times 1520, that was like plus 500, right? And I think it's 310. So sell each tablet for $310 and then you will make the most amount of money. There was a bit of guesswork in this kind of stuff, right? Because you guessed that you would sell 80 more tablets when you decrease the price by $10, right? So that is maybe not be, this does hinge on that assumption.
So that's saying that at 310 you'll sell 1,525.
Yep, and that will, and if you do that, you'll make more money than having the price be lower and selling more. Does that make sense?
You don't have to do the second derivative test because it's possible.
And I kind of forgot to in the previous problem, but you could do the second derivative test because look at this thing. The second derivative is going to be -1/4, which is less than 0. So we're concave down, which implies we have a max. Does that make sense? But if I didn't ask you to justify your answer, you don't have to. But yeah, so the second derivative test would tell you for sure that you're making the most money as opposed to like making no money. But you probably would make no money if you sold the tablets for nothing, right? Or you sold them for, if you had them priced too high and also sold none, right? Okay. Let's do one more question, we'll take a break and we'll come back and do the rest. So suppose you have a parabola, 8 minus x squared. So what does that parabola look like? Shifted up 8, and is it upside down or right side up? Upside down. Okay. And you want to inscribe a rectangle, as in put a rectangle inside of this parabola. My rectangle looks a little bit square, but you know, that's okay.
A square is a rectangle.
Exactly. I know. Okay. So you want to find the biggest such rectangle that you can cut out. And this might apply to like say if this was instead of a parabola, it was a circle and you're cutting out the biggest possible board from that circle. Like it's like how do you make the biggest log out of a, biggest square beam out of a log. Same kind of idea. So does it make sense that the area of this thing is that dimension times this dimension? Does that make sense? Okay. So now in terms of the x and y axis, this little box, the one that I've shaded right there, its area is x times y. Because if you got this point, x is how far over, y is how far up, right? So how would you find the area of the whole thing? 2xy. And that's because this parabola has some symmetry. If I'd given you like an equation of a line, you might just have xy in that case. Does that make sense? I would have to specify that was bounded by like the x and y axes as well, but it's because that spans over that you do xy. And it's also said above the x-axis. I know it doesn't go below. I think your homework question has something inside of an ellipse. So in that case, you have something kind of like this. It'd be 4xy in that case. Yep, exactly.
It's how many times it cuts in half.
It's how many times it's cut in half. Yep, it's how many pieces the axes divided into. Definitely. And once you get that, where that 2 comes from and y, this one's actually pretty easy because you already know how to relate x and y together, don't you? Because there is that corner of that square is on that parabola, right? Which means that the y and x related by that equation, the 8 minus x squared. So the area is 2x times 8 minus x squared, or 16x minus 2x cubed. Does that make sense? And so can you find the maximum of this function now? Yeah. A prime will be 16 minus 6x squared, right? So set that equal to 0. 6x squared equals 16. X squared equals 16 over 6. So x equals, 4 over root 6. And I don't care to rationalize, that is totally good enough. Okay, and before we find the other dimensions, let's just figure out what the others, if it's a max or a min. So what's the second derivative?
12x.
Almost. Negative 12x. And a prime prime of 4 over root 6 is less than 0, right? Some negative number. So a is concave down, thus max, right? Okay, now that we know the x, can you find the y? Plug it into the y equation, yep, so y will equal 8 minus 4 over root 6 squared. So 8 minus 16 sixths. So that's 48 6 minus 16 6 is how many 6? 32 6 or divided by 2, 16 over 3. Okay. Now the one tricky thing about a lot of these questions is just making sure that you've answered what they've asked. They want the dimensions of the rectangle. So what is the base of the rectangle? Is it just 4 root 6? It's, the base is 2 times 4 over root 6 or 8 over root 6. That x just found the distance from the origin over, right? So just be careful about stuff like that. And then the height is just that 16 thirds. Sometimes with these questions, they're going to ask you for the area, in which case you guys actually have to multiply the base times the height. And the most common mistake is students leave off that 2.
If we were in the ellipse, you'd actually,
If you were the ellipse, the x would multiply by 2 and the y would multiply by 2. Yep, exactly.
is there any other weird ones besides these two?
No, I mean, it's just looking at the picture. I mean, because I could also look at an absolute value function. You'd have to do something like funky with it as well, right? So, yeah. Okay, let's take a quick pause and then we'll finish the rest of them. Actually, it's kind of cheesy. I did a cheesy question, then I did one that made more sense that's related to the cheesy question. The cheesy question is a textbook question. So you have a guy and he has time to plan for some reason. He is on a river and he can take his boat and he's going to go across the river on the boat and then run down the stream. But he can run faster than he can row, and so the question is, how can he get from point A to point B on the opposite side of the bank as quickly as possible? So here's what the picture kind of looks like. We do assume the river is straight, which I know in Alaska is totally not a valid assumption. But you have this guy at point A, he wants to get over to point B, and the question is should he go over to some point C and kind of row this much and then run this much?
Was it going upstream or downstream?
That's not actually told, but we are told how fast he can row and how fast he can run. So it doesn't really matter if it's up or downstream, because even if it is downstream, he's still faster running than rowing.
They seem to do this a lot. Either
Does that make
swim or
sense?
run or-
Yeah, swim or run, but the next, example 8 will have an application that's less stupid, I promise, okay? So what do we know about the river? How wide is it? 3 kilometers, so this is 3 kilometers. Okay, and I'm going to call this distance of that triangle x. And how far down was it to point B?
8 kilometers.
8 kilometers downstream. So that means that the distance from this point straight across from A to B was 8 kilometers. So how far is it from C to B?
8 minus 6.
8 minus x, very good. Does that make sense? The downstream meant like, it's 8 kilometers downstream, like not the hypotenuse length.
Okay, so the whole thing that goes straight across
Yeah, the whole thing, if you went directly across from A and then down to B, it's 8 kilometers. That's what that meant. Okay. So I'm gonna just write this down very generally. The total time it takes is equal his row time plus his run time, right? That's the thing you want to find the minimum of. You want him to get across as quickly as possible, and it's going to be how much time it takes him to row plus how much it takes him to run. And to do this, you use the fact that this distance equals rate times time from it. We do assume his speed is constant, like there's no obstacles that affect his 8 kilometers per hour and stuff. So for the let's just do the row time. Let's let that be T1 because he does that first, okay? How far is the distance he has to go with his boat? Like, what is the length of the distance from A to C? Root x squared plus 9. Does that make sense? So we have root x squared plus 9 is his distance. Do you know his rate at which he can row? 6 times T1. So T1 will be equal to 1/6 root x squared plus 9. Does that make sense? Because we know the distance is that expression that has the x squared in it. The rate is what we were given in the problem. Okay, how about the run time? Let's let that be T2. What is the distance that this guy has to run? 8 minus x. What is the rate at which he can run? 8 kilometers per hour times T2. So then T2 will be 1 minus 1/8 x.
That's an 8 times 2.
That is an 8 times T2, yes. Yep, so time it's going to take him is going to be 1/6. I'm just going to write that as x squared plus 9 to the 1/2 power, because I got to take the derivative already, eventually, plus 1 minus 1/8 x. Okay, so take the derivative. So t prime will equal 1/12 times x squared plus 9 to the what new power? And then don't forget your chain rule. Times 2x, very good. And then plus 0 minus 1/8. Okay, set that equal to 0. We get x over 6 root x squared plus 9 minus 1/8. I'll stop and let you make sure that you understand, but if you forget the chain rule, you're going to be screwed. So don't forget the chain rule because you're going to get things that make no sense. Yeah, what'd they make you do in pre-calculus?
It was like a lot of, it was kind of like the time was time, but it was like,
They probably tried to make you solve that equation and find the max or min using like a graphing calculator or something like that, maybe? No? Okay, well, I don't know what they did. Because you can't do the max min without a calculus. You can, but you'd have to either have a very nice problem or a graphing apparatus to get it usually. Okay, so can you now solve this for x, possibly? How about you add the 1/8 over? And you have heard of cross multiplying, right? So like you can say this is 6 root x squared plus 9 equals 8x, right? Does that make sense? Good. Okay. Now square both sides, and if you square both sides, you have to also square the 6. So square both sides means square the entire thing. So you get 36 times the quantity x squared plus 9 equals 64x squared. You could kind of reduce before squaring by dividing both sides by 2, but you know, whatever, it doesn't matter. So you get 36x squared, oh God. 270 plus 54, 324? Yay, woohoo! Arithmetic. Arithmetic under pressure. Oh no. Okay, so 324 equals 64 minus 36.
28.
Woohoo! Yay for making you subtract for me. X squared equals 324 over 28, and because I have my notes, I know that reduces to 81 over 7. And so x equals 9 over root 7. And obviously not negative, because he's not going to go backwards. That'd be dumb. Yeah, unless it's a really bad river, but we don't assume that that's the case. Now this is one instance in which I think taking the second derivative might not be very pleasant. Does that make sense? Because you'd have to use the quotient rule on that x over the 6 root stuff, right? So in that instance, the other way that you determined a point was a max or min is you use the first derivative test. Does that make sense? And in this case, it's also pretty easy to spot the domain, because that picture you had, your x is between 0 and 8. Does that also make sense? 0 would correspond to, in this picture you had, going like this. Does that make sense? And 8 corresponds to doing that, right? I think that's right. If x is 0, they got them backwards. If x is 0, this point's over there, so that does correspond to that. If x is 8, I just moved it so you can see the picture. I moved it back up now. Okay, your critical number is somewhere in the middle, 9 over root 7, whatever. Let's test some numbers in your derivative. So we're going to test in f prime. And technically, you can actually test 0 and 8 if you want to. Pretty easy. So if you plug 0 into this, what's the sign of f prime going to be? I think it's going to be negative, isn't it? Because that 0, plugging in 0 zeroes out the first thing, right? And I'm pretty sure that when you plug something like 8, this ends up being positive. So it goes, decreases, increases, which means that x is 9 over root 7 is a min by the first deriv test. Your book, when it explains this example, does it differently. It actually plugs the 9 over root 7 and the 0 and the 8 in and compares them, but I think that's a little bit, so I think this is easier. If you know that from the first derivative test is a minimum, you don't have to test the endpoints. Because you know it goes down, it's the only critical number. It has to do this kind of swoopy thing. So, okay, but most students hate this problem. They're like, this is stupid. I would never figure out where I had to go. I would just kind of like paddle and just kind of guesstimate, right? So in this situation, sure, maybe you would guesstimate, but 3 kilometers is a really wide river, right? So maybe the guesstimation is not such a good idea in this situation. But in example 8, it's a question, and this makes a whole heck of a lot more sense. So you would not want to guesstimate with this. So you're building a refinery, and your refinery is on the north bank of a straight river, and you're going to construct a pipeline from your refinery to your storage tanks, and you have to go under the river and then along the bank. Okay, so call that the refinery, call this the storage tanks, and this is, once again, across the river, but you could imagine just situations in which the terrain changes. You have like, okay, across a mountain range and over a tundra or something, and the costs are different in different places. So refinery and your tanks. And the river in this case is 2 kilometers wide. And the question is, where should that point P go to? You're going to go some underwater, and you're going to go some over land. And the cost of laying pipe is $10,000 per kilometer over land and $40,000 per kilometer under the banks, under the river. So it makes sense you probably want to get across that river as quickly as possible, right? But because you would use more pipe or more stuff if you just went straight across and then straight down, it might be better to go a little bit more expensive under the river, but minimize the distance a bit, right? Okay. So once we're going to set it up almost the exact same. We're going to call this X. It was 10 kilometers downstream, so what is it from P to T? 10 minus X. Okay, and the cost is the cost for going under the river plus the cost for over the land along the bank. So how would you figure out how much it will cost you to go under the river? You know how much it costs per kilometer, right? You know how many kilometers it is to go across, right? So how far is it from there to there? Depends, right? So it's x squared plus 4, right? So that part of the cost will be 10,000 times root x squared plus 4, right? Oh, that's wrong though. That should be the 40,000 one, shouldn't it? Under the river one was the more expensive one.
Yeah, that's what.
Okay, yep, whoops.
we're worried about.
How about the overland cost? That's gonna be 10,000 times 10 minus x. And at least in this situation, it makes a bit more sense that yes, you want to find the actual best point as opposed to some guesstimate, because in this case, it's a lot of money. Okay, so let's go ahead and find the derivative. So it'll be 40,000 times a half x squared plus 4 to the negative half times 2x. And then I think it's just gonna be minus 10,000. Did you agree with that? Okay. Set it equal to 0, yep. The 2's go away, the constant goes away. So 40,000 times x over the root x squared plus 4 minus 10,000. So add the 10,000 over. Kind of cross multiply. So you have 10,000. I think I added an extra 0 there. Whoopsies. So 10,000 root x squared plus 4 equals 40,000 x. And before you square, I would suggest dividing out that constant. Do you see what I mean? Like you can say root x squared plus 4 equals 4x, right? It's way easier, right? And from there, it's not that bad, right? Solve, you get x squared plus 4 equals 4x. Or equals 16x squared, sorry, yep. More coffee. So 4 is equal to 15x squared, right? 4/15 equals x squared. So x equals 2 over root 15. And what's the range of values that x can be in this case? What's the lowest x could be? What's the highest x could be? 10 in this case. And 2 over root 15 probably is closer to 0 than to 10, right? Okay. And I'm pretty sure if you test numbers again, you're going to get the same negative positive thing going on. So by the first derivative test, we have a minimum. And kind of a cool thing about this question that actually I think is kind of neat, it doesn't matter. You could also phrase this question in terms of the pipe under the water costs 4 times as much. Because you could have just made this, instead of 40,000, into a 4, and this into a 1. Because you're going to end up with the same result once you get to this step. The actual specific costs don't matter. What matters is the cost relative to each other. Does that make sense? So that's kind of, you could say, okay, the pipe cost, I had a different book that phrases the pipe underwater costs twice as much.
So the under the water part is 2 root 15, whatever distance that is?
The 2 root 15 tells you how far from straight across from that refinery that point should be located. It tells you how far over it should be.
So we'd plug that in that distance or
What do you want to find?
hypotenuse?
Do you want to find, oh, to find the hypotenuse, yes, you could plug that number into the root x squared plus 4 equation.
I
Yep.
was curious what the actual cost.
Yep. And well, to find the actual cost, you could just take this equation, that x you got, and plug it into the cost equation. Because that cost equation has both the hypotenuse, right, and the overland part into it, and the cost per unit of like length as well. So that cost equation tells you a cost given a specific location of that point P. Because what you were kind of doing was talking about sort of re-engineering that equation again.
Yeah.
Is that before that specific value of x? Isn't that kind of a neat application, like a little bit? Okay.
I'll plug it in the calculator when I get home and see if it really saves money.
Okay, sounds good. All right, so the next ones are actually easier because apparently I just did a bad job putting this together. So you have a piece of paper and you want to contain 24 square inches of print. Like you're making a poster for your movie. Really great poster, it has a stick person on it. Okay. The margins at the top and bottom have to be 1.5 inches. This must be 1.5. This must be 1.5. And this must be 1, and this must be 1. Does that make sense? Okay. All right, I'm going to call the little base of this thing x and the little height of this thing y. And by that I mean of the printed stuff. Like the part that contains the print. I'm going to call that distance from printed part to printed part x, printed part to printed part y. Is that the best way? I think it is. What does x times y have to equal? The area of the printed stuff, which is 24. Yep. So that's the printed part. It'd be, well, you don't put the label right there, but yeah, it would have been, because it's 2-dimensional, it would be inches squared. Say that again?
You subtract it from the bigger part.
I didn't subtract anything quite yet, but I just said that the x part that I called, the part that I call x is just that part. You can just use to define your variables however you want, but I'm saying that x is the leftmost printed part to rightmost printed part.
Oh, I was asked, I said on the next step.
Oh, the next step will be you're going to actually add it. So for the total area, how far is it from here to here? So if this little bit in the middle is x, this is now 2 plus x. Does that make sense? And this part is now y plus 3. Do you guys agree with that? So the area of the whole page is y plus 3 times 2 plus x. And that's the thing you want to find the minimum of, because you want to use the least amount of paper, right? And you're going to probably incorporate this somehow, but I would suggest first multiplying that together. So a will equal xy plus 2y plus 3x plus 6. Man, that was messed up. But I think that's all of them. 2y, yx, 6, and okay, good. Now here's some clever things. What is x times y? Look at that, lovely. Yeah, let's plug that in right now. Okay, what can go in for y? 24 divided by x, lovely. Plus 3x plus 6, and there. We have our area equation is 48 over x plus 3x plus 30, all down to one variable. Woo, we're in business. So now can you take the derivative of this and do all the stuff you gotta do? What's a prime gonna be? Great. Plus 3. Set that equal to 0. So 48 over x squared equals 3. 48 equals 3x squared. I think that's 16 equals x squared, isn't it? So x equals 4. And actually, I think right away you can say that y is equal to 6. Now let's just verify that that's actually we want a minimum, right? So what's the second derivative of this thing going to be? So look at this guy. Positive or negative? Positive 96 over x to the third. So a prime prime of your critical number 4 is positive, right? A is concave up, thus min or max. Min, which is what you wanted, right? Woo! It won't happen very often, really. I mean, there was only one example where it happened. That example was weird and tricky, right? It's not going to happen very often that you're going to get the wrong thing. And if you do, you might have some kind of endpoint situation where you use the endpoints. That is how you would deal with it. Okay, so this asks for the dimensions of the page. If they want the printed area, they're going to specify printed area. Does that make sense? So the base of the page is going to be 6 inches, and the height is, yep. So my suspicion is the most common mistakes you're going to make on stuff like this when you're solving, other than not having a clue what to do, which is also a mistake, but that's not one I can diagnose, but will be not answering the question correctly, like getting the right answer, but not quite phrasing it the way that they want. Okay. So an open box of, there you go, here's your question. The open box of maximum volume is going to be made from taking a square piece of material, 30 inches on a side. So it's 30 by 30. Just pretend that I can draw a square, which is not a valid assumption, but we'll pretend. And we're going to cut out equal squares from each side. And then we're going to take out those squares, so they're gonna be gone. So I'm just gonna put X's in them. They're away. And you're gonna fold that up, and that makes a box with an open top, right? Okay. So you wanna figure out how can you make a box that has the biggest volume. So I'm gonna call this little side X. And I'm gonna draw in dark black, that's the base of my box. So this little side I cut out is called X, that little side's X. What's the length of this from there to there? 30 minus 2x. And what's the length of this side right there? Same thing. You guys did a question like this earlier on in this class. I think I made you set up this volume equation. So the volume of this box is 30 minus 2x times 30 minus 2x times one more dimension. What's the last dimension in this box? X. Is that okay? If the piece of cardboard was not a square, the length and width of the base would be different, right? But this one is a square, so they're the same. So that'll be 900 minus, I think, 120x plus 4x squared, all times x, or 4x cubed minus 120x squared plus 900x. That tells you the volume given a specific x that you're going to cut out. Does it make sense that x must be in between 0 and 15? Because 0 means cut out nothing, right? Why 15? Once you've done it, you cut the box into 4 pieces and there's no more box, right? Okay. Okay, find the maximum then. So v prime is 12x squared minus 240x plus 900. I hope we don't have to use the quadratic formula. Oh. 0 equals, does 12 go into 900? Oh, how many times? Great. X squared minus, it's going to be what? 20x plus 75? I think that this problem was designed to be lucky. Because I think it even factors. I think 15 times 5 is 75. Am I right?
Yep.
So I think that's x minus 5, x minus 15, right? Do you agree with that? That was lucky. So the numbers you found are x equals 5 and 15, right? So the second one, the 15, makes no box. It makes no sense. That's a minimum value. Does that make sense? Okay. X equals 5. How would you verify that that made a max volume? You'd find probably, I'd use the second derivative because it's not very hard to find it. So 24x minus 240, and that's just a terrible v. And it did it again, whatever. Okay, so v prime prime of 5.
Looks like an upside down Eiffel Tower.
It looks like an upside down Eiffel Tower, yes. I was thinking upside down A, but it's even more artistic. It's Eiffel Tower. Okay, so when you plug in 5, 24 times 5, is that 120? And so this is just the point is it's negative, right? So V is concave down. Thus we have a maximum. So the answer is cut out 5 by 5 inch corners. Which means the length of the base would be 10 by 10, right? No, 20 by 20. Yeah. I should have done this problem first, but hindsight is 20/20. A rancher has 800 feet of fencing with which to enclose 3 adjacent rectangular corrals. What dimensions should be used so that the enclosed area is going to be a maximum? So the idea here is you want to make pens and you want to keep certain animals separated from each other. There's your black sheep, your white sheep, and your gray sheep. I don't know, something like that, right? Something like that. Well, we're going to separate the sheep by color because you want to make that you can dye this, you can't dye that, and this makes nice black sweaters. Okay, it's a racist rancher. So I'm going to call, we shouldn't joke about racism. We're going to call this side X, and I'm going to call this side Y. And we're going to assume that they're all equal size. Oh man, that would make a bad separate but equal joke. Terrible. Terrible. Okay. Alrighty. So tell me an equation. So you want to maximize your area. So the area is x times y. And the perimeter in this case is how much fencing you use, but the perimeter is not just the distance around the outside, it's also the stuff in the middle. Does that make sense? So how many x sides do you have and how many y sides do you have? I think there's 4 y's. Yes, you have to actually count them.
Well, there was a fence.
Oh, there's a fence, yes. Okay, and that, how much fencing you're gonna use is 800, right? And because I have all even terms, I'm just gonna divide everything by 2. So I've got 400 equals x plus 2y, right?
Each have these square pens and wouldn't y be 100 x?
I don't know if that's the relationship. There probably is a relationship that's consistent, like, between where this kind of shaped pen, but I'm not sure if that's it. Yeah.
Is it 4y because there's like separating?
The 4y is because they want to make 3 corrals, so they have 1, 2, 3, 4 pieces, because they also have one on the outside. Okay, so to put these equations together, is it easier to take this equation and solve it for x or solve it for y? For x. So x will equal 400 minus 2y. So my area is 400y minus 2y squared. And I used to give my poor, unsuspecting Algebra 2 students these questions because that's a parabola, right? It's a negative parabola, so it's upside down, therefore it has a maximum. You can do this problem with no calculus. It's just easier with calculus. Okay, so how do you find the max? Take the derivative, and the derivative is 400 minus 4y, set it equal to 0. So 4y equals 400, your y is 100. And then your x is going to be 200. And as long as you have a picture that explains to me what x is and what y is, don't specify what's what. Does that make sense? WebAssign will say something like the side that's dividing the fences, the pen up, or they'll have a picture that explains what how your variables are represented in the picture. Let's just make sure that that's a max. It's a max as a prime prime equals -4, right? And that's -4 always. So thus A is concave down.
For the quiz, are you gonna be wanting us to justify?
And it says so in the directions on all of them. Did you guys ever learn that the vertex of a parabola is at x equals -b over 2a?
Yes.
So a parabola is ax squared plus bx plus c. How would you prove that that was true? At the vertex of a parabola, what is the derivative? 0, it's the vertex of a parabola always is a max or a min, right?
Yes.
So at the vertex of a parabola, the derivative is 0.
Yeah.
So y prime is equal to what?
2ax plus b.
Set it equal to 0. Solve it for x.
Yeah.
Negative b equals 2ax, x equals. That's where it comes from. You can prove it without calculus using completing the square. That's also possible, but it's a lot more ugly. This is much faster and cooler. Okay, so last question. This was on the BBC's website, and I thought it was fun because it was calculus, and all these students in the UK were stumped by this question. Like, that's like basic calculus 1. And it has a crocodile and a zebra, so it's kind of cute. So you have a crocodile, and it's stalking its prey, and it has the fun British spelling, located 20 meters further upstream on the opposite bank of the river. And the time for the crocodile to reach its prey can be minimized. Oh, look at that, it has an S in the minimized, it's so cute. If it swims to a point P across the bank and then runs upstream. And it even told them the time T it takes the crocodile to go is given by this equation. Okay, so they incorporated how fast the crocodile can go swimming and running on land. So they told you what that equation was. So calculate the time taken if the crocodile does not travel on land. So for I, look at that picture. If the crocodile does not travel on land, then x is equal to, I think that would be equal to 20 actually. Does that make sense? Because x is how far over p is, and if he doesn't go on land, that p has to be all the way over here. So that x has to be 20. So t of 20 is going to be 5 root 36 plus 20 squared, plus that last term is going to be 0, right? You buy that? So that's 5 root, I think, 436, whatever that is. Some decimal answer. I think they were probably given a calculator on this question. I don't know what it was, but let's see. So it's 104.4. And it was tenths of a second.
Four-tenths of a second.
So that'd be 10.44 seconds, wouldn't it? Because it says it was measured in tenths of a second. Okay, this double I says calculate the time if the crocodile swims the shortest distance possible. So that means that the crocodile goes straight across and then down the bank, right? So that corresponds to x equals 0, right? So in that case, t of 0 is 5 root 36 plus 4 times 20 minus 0, which is 30 plus 80, right? Or 110 tenths of a second. You guys buy those things?
What's that?
Do you understand those? It'd be easy to mix them up, but I mean, you can do the math the British kids couldn't do. Okay, and the last question says, between these two extremes, there is one x value that minimizes the time taken. Find this value of x and hence calculate the minimum possible time. So what are they referring to there? Take the derivative, right? Exactly. So t prime of x is 5 halves 36 plus x squared to the negative a half, right? Times 2x. And then I think just minus 4.
Yeah.
Yeah. So 0 will equal 5x over root 36 plus x squared minus 4. 4 equals 5x over the root 36 plus x squared. So 4 root 36 plus x squared is 5x, and it's almost the exact same as the ones we did, right? So 16 times 36 plus x squared equals 25x squared. So that's 576 plus 16x squared equals 25x squared. I think 576 is a nice square root, doesn't it? I don't know why I wrote 579. That was a mistake. 24? Yeah. That means x has a nice answer even. So if you root both sides now, you get 24 equals 3x, right? And so x equals, is that right? Yeah, 8. Okay. Oh yeah, I can move it up. No problem. And then to find the minimum time, what do? You plug 8 in, yep. They didn't even make these kids justify it was a minimum. 5 root 36 plus 8 squared plus 4 times 20 minus 8. And I think it even worked out to be a perfect square, didn't it? Because that becomes like root 100. So that's 50 plus 4 times 12, what, 48?
Correct me if I'm wrong, but isn't any perfect square plus a perfect square also a perfect square?
No. 1 plus 4.
1, 9.
Yeah. Okay, no. So 98 tenths of a second. Anyhow, apparently this problem was controversial and people couldn't do it and it was a big deal. But I don't know how much math these kids are supposed to know by this point in time in their lives. Like maybe it's not, they don't have calculus yet, but yeah.
This next
Not
one
fair.
apparently didn't win the Revolutionary War either, so.
Yeah, so anyway, that was I thought it was kind of cute. And I was like, that's just basic calculus. And somebody, of course, made a YouTube video. It's like, yeah, you just find the minimum of this. And they did it in, cute British English.
Were they algebra 2 kids?
It's not, I couldn't.